First question. Is R continuous at t equals 5? Show the work that leads to the answer. So, continuity on a piecewise function, that should be par for the course at this point. I'm going to take the limit as t goes to 5 from the left side of 600t over t plus 3. Well, what is that? I'm in a pretty good position. I think I'm in a safe enough position to let t go to 5. 5 plus 3 is 8. And up here I get 3,000. So 3,000 divided by 8. Okay? Going to be some number. Let's take a look. I'm actually already leaning towards no because I'm thinking that with an e being in the function, we're not going to be continuous. So I get 1,000 e to the negative 0.2 times 5. I'm going to go and calculate that. What do I get when I calculate it? I get this 367.8794. So I already did the calculations before I resumed the video. So 367.879. So 367.879. So we can say that no R of t is not continuous at t equals 5 because the limits from both sides do not agree. So far, so good. Okay, so let's move on to part B. Part B says, find the average rate at which water is draining out of the tank between 0 and 8. Well, how do I do that? I'm going to integrate, but I'm still going to multiply by the 1 over b minus a, except that's going to get multiplied by two integrals being added together. So it's going to be starting from 0 to 5, and if I only go from 0 to 5, I'm going to use this top function here. So 600t over t plus 3 dt. And then from 5 until 8, I'm going to do 1,000 e to the negative 0.2t dt. Let's find out what each of those, let's find out what each of those is. Darn, go away, thank you. There we go. Let's find out what each of those values is. So I go to my trusty calculator here. So what I'm going to do is I'm going to go and just add those up first, and then I'll divide the whole thing by 8. So I got shift plus here. I'm going to go from 0 to 5 of, actually you guys don't need to see this. So after some button pushing, this is what I've got. I'm going to go and find out the value. So I've integrated both, but I have not yet divided by 8. So I'm going to go and divide by 8. And I end up with this 258 type number. Let's split screen this like Nintendo 64. So I end up with 258.0527. Now, did they ask me to do any kind of units or anything like that? Did they say that? It does not say any kind of units, so I think we're good. Just find the average rate. Cool. All right, part C. R prime of 3. Well, we got to find it first. What's R prime of 3? Well, R prime of 3 is going to be using this dude, right? This guy. So that's going to be the derivative of 600t d over dt of 600t over t plus 3. But I want that at t equals 3. So I'm going to punch that into the calculator and go derivative at a point on this thing. So what I'm going to do is I'm going to go ahead and go menu, calculus, derivative at a point, value is 3, and I'm going to go, instead of doing F1 and F2 and all that stuff, I didn't put that in the calculator, I'm going to go and just type in the manual function, so 600x over x plus 3. And I'm going to go ahead and derive that. Bam! It's 50! Okay, good for us. So that's a pretty easy number to do. So that is 60, right? Oops, 60? I said 50. It's 50 So what does this mean? Well, what this means is that since I got a positive rate, that means that the rate at which water is draining is increasing at 50, I believe it's liters per hour squared. And the reason why it's per hour squared, and I have no other way of doing this other than to do that, per hour squared, is because we derived with respect to time on an already established derivative. So it's akin to acceleration in this problem. Okay? Sweet. Part D, our favorite part. Even more our favorite. Write but do not solve. Awesome. Write but do not solve an equation involving an integral to find the time of A when the amount of the water in the tank is 9,000 liters. Okay. Well, if I'm trying to find out the amount of water in the tank, I need to find out how much water was initially in the tank, and then I'm going to subtract all the water that was drained out between 0 and some time A. Okay? Well, remember, this rate here, this R of t is the rate at which water drains. Now, where's A? I have no idea. A could be in between here. A could be in between here. All I know is that the amount of water that was drained out on a period of 0 to A of this function, I want there to be 9,000 gallons remaining. So this is the remaining water, right? That's what that is. This is the drained water. And how much water did we start off with? I believe it told us. It says we started off with 12,000 liters. And if we started off with 12,000 liters, I'm going to subtract the amount we drained. And so this is the start H2O, right? And I want that to be 9,000, so I've set it up. We started off with 12,000. I subtracted how much we drained out, and I end up with 9,000 liters. Does it call for units of sorts? Actually, no, it says write but do not solve. So I think we're good. That's all there is to it to this problem. All right, see you guys in the next one.